prime numbers. You've heard of them before. They're kind of the celebrities of mathematics. But what you may not know is that prime numbers can be kind of unpredictable. We know that 2, 3, 5, 7, and 11 are prime, but we don't really have some kind of formula that tells us what the next prime number in the sequence will be. We kind of just have to pick a number and check. But what does this have to do with you becoming one of the greats? Well, we'll get to that in a second, but first, how many prime numbers are there in total? It turns out there are infinitely many prime numbers, and I can prove it. Short disclaimer, this proof was invented by a 2,300-year-old man, but he isn't available right now, so I'll have to demonstrate his proof myself. Imagine there were only a finite number of primes. That would mean that you could write a list of all the prime numbers in existence, and that list would end somewhere. Let's call the last prime on that list n. Now imagine taking all the prime numbers on that list and multiplying them together. Let's call the result p. What are the factors of p? In other words, what numbers divide into p evenly? Well, 2 certainly is a factor of p, since p is a multiple of 2. 3 is also a factor, and so are all the other primes on this list. Now let's add 1 to p. What are the factors of p plus 1? Or in other words, what numbers evenly divide into p plus 1? Well, 2 certainly isn't a factor, because 2 divided evenly into p, so it's not going to evenly divide into p plus 1. 3 isn't a factor either, because 3 divided evenly into p, which means it's not going to evenly divide into p plus 1. None of the prime numbers are a factor of p plus 1. And as it turns out, none of the non-prime numbers, also called composite numbers, are a factor of p plus 1 either, because all composite numbers can be broken down into prime numbers. For example, 4 is composite, but it can be broken down into 2 times 2. So if 4 were a factor of p plus 1, then 2 would also have to be a factor of p plus 1, which we know it isn't. That leaves us with only one option. If p plus 1 doesn't have any factors, other than 1 in itself of course, then it must be prime. But we already established in the beginning that this was the set of all prime numbers, and this list doesn't include p plus 1. The problem is, you can always add another prime number to this list by multiplying all the primes together and adding 1 at the end. Hence, there are an infinite number of primes. What we just did is called a proof by contradiction. Mathematicians use it a lot to prove stuff. We assume something to be true, and when it doesn't make sense, we conclude that what we assumed must have been false. But here's where it gets interesting. Because there are infinitely many primes, that means that whatever prime number you can think of, there's always one that's larger. What's the largest prime number known to date? It was discovered not too long ago, December 7th, 2018. Here it is, 2 to the power of 82,589,933 minus 1. How big is that? Start with the number 2. Double it. Double it again. Double it 82 million times. The number you get is 24 million digits long. Subtract 1 and you're left with the world's new largest discovered prime. It's called a Mersenne prime, which is a specific kind of prime that can be written as 2 to the power of something minus 1. 7 is an example of a Mersenne prime because it's 2 to the power of 3 minus 1. The 14 largest known primes are all Mersenne primes. But why? The reason is that it's really easy to check if a Mersenne number is prime. There's a primality test specifically for the Mersenne numbers called the Lucas-Lehmer primality test, and it's faster to use than other primality tests, so that's why we keep checking Mersenne numbers for the next largest prime. This newest Mersenne number was discovered by Patrick Laroche, who was one of many contributors to the Great Internet Mersenne Prime Search, or GIMPS, a program where anyone in the world can contribute some of their computer's CPU power to hunting down the next largest prime. If you join the program, you could be the next person to be etched into the history of mathematics as the discoverer of a new prime number. You could become one of the greats. Join me in part 3 where we'll answer the age-old question. If numbers were people, which number would be the most popular?